Okay, so we already learned integration by parts. Very good method, so that way we can integrate other integrands. I don't want to say equations, they're integrands. They're expressions after the integral, either with respect to x, so we write dx or dy. But you can see how they kind of go hand in hand, where we need the dx there, especially if we're trying to establish dv and find v. So here we have a tabular method to do integration by parts. This is if we can establish an f of x and a g of x. So let me go over. So when we establish f of x, we want to establish f of x to be something where the derivative repeats and it becomes 0. That's very important. And I wish I wrote 0 much better than I did. That's supposed to be the word 0. All right. I'm sure you can write it better as you are writing these notes, because you should be writing these notes. Okay. So we also need to establish g of x. And g of x has to be something where the integral comes easy repeatedly. I'm abbreviating the word repeatedly, I'm abbreviating the word derivative, I'm abbreviating the word integral. So, for this particular example, I would establish f of x as x cubed, because eventually I should get 0 for its derivative. And g of x, if I took its derivative, I wouldn't get to 0, so I'm not going to make that f of x. G of x would be sine of x. Okay, so f of x is one of the factors in our integrand, and g of x is the other factor in our integrand. Okay, if we can establish that this is true, okay, and g of x is true, we just went through why f of x is true, okay, and eventually the derivative becomes 0. G of x, we can easily write out the antiderivative or an antiderivative for it, which is negative cosine of x. So what we're going to do, as you're watching me keep taking the antiderivative here, and I can actually keep going. And I'm running out of space. So what we're going to do is establish a table. So the table should actually first be done with the f of x, because I was having too much fun with g of x. Let me show you where we do f of x first. So we're going to take the derivative of x cubed. It's 3x squared. We're going to take the derivative of that. 6x. We're going to take the derivative of that. 6. Then we're going to take the derivative of that. You have to keep taking the derivative until you get to 0, and you stop. And you now finish your table with doing the antiderivative for g of x, which we actually did already. So I don't need that portion of it, and that's why it's so important to actually start with f of x and don't go too crazy like I did. But that was fun anyway, right? So far, so good. So you're probably wondering, what in the world are we doing? Okay, we're going to evaluate the integral of x cubed sine of x dx, okay, by using this tabular method. So the first expression for f of x, okay, will actually be multiplied with this expression here. If you remember u times v, okay, negative cosine of x. And it is positive, okay? Instead of continuing to do the integrand part, the integral of v du, we're going to continue to group these as such. See my arrows? The 6 will be grouped with sine of x. And we continue from doing positive signs to negative signs, then back to positive signs, as many as we need, negative signs, of these multiples, of these factors. Okay, we're going to multiply them together. So our answer here is going to be a positive x cubed times negative cosine x, and a negative 3x squared times a negative sine of x. Okay, you can see that here. And then we're going to have that positive again, but this time with 6x times cosine of x, and negative 6 times sine of x. And if we're evaluating an indefinite integral, our final answer will have a plus c. So what does this all equal? Let's make it nice and neat. So this answer is, okay, if we multiply this out, it becomes negative x cubed cosine of x plus 3x squared sine of x plus 6x cosine of x minus 6 sine of x plus c. So the reason we do this is to quickly get the answer, so we don't have to do integration by parts over and over and over again, as we probably would to get this answer. So the other reason is because we can. Just make sure that you do have f of x as a derivative that becomes 0, and g of x as something where we can easily take the antiderivative. All right? So keep practicing this method, and good luck.